Now let's discuss some of the research methods used in the field of epidemiology: observational, prospective, and retrospective studies, natural experiments, and experimental studies. Epidemiology is a branch of medicine that investigates factors contributing to increased health or occurrence of a disease in a particular population. Epidemiology did not evolve as a science until the 19th century, when infectious diseases threatened lives of millions. For example, John Snow observed the distribution of cholera deaths in a southern section of London. Two different companies were supplying water. The pattern of cholera deaths closely paralleled the distribution of polluted water. 30 years later, Koch isolated the cholera bacterium. Identifying risk factors does not prove causation, but it's a first step leading to control and eradication of a disease. There are three basic purposes of epidemiological studies: to determine etiology of disease. For example, AIDS was noticed to be prevalent with certain populations, and body fluids seemed to be involved. To determine whether hypotheses developed from other studies are consistent with epidemiological data. For example, physicians noted heart attacks were more common in women who were overweight. Researchers examined whether obesity was related to heart disease in women. Yes, it is. To provide a basis for developing and evaluating various preventative procedures. For example, testing large groups to demonstrate overall effectiveness. There are three broad methods of epidemiological studies. The first is observational. Observational studies are similar to correlational studies because they show association, but neither can be used to demonstrate causation. For example, men with type A personalities, perfectionistic, time-urgent, sometimes hostile and suspicious, were twice as likely to experience coronary heart disease. This was a prospective study because individuals were followed over time and did not use correlation, but it suggested a link. Prospective studies. Prospective studies look forward in time. These studies begin with a population of disease-free participants and follow them over a period to determine whether a given condition, like cigarette smoking, is related to a later condition, like cardiovascular disease. Researchers might intervene in the diet of one community and not in another, and over time look at the differences in rates of heart disease. An example of this type of study would be the Nurses' Health Study. The study started in 1976 and studied risk factors for major chronic diseases in women. The study followed 122,000 RNs in 11 states, investigating the impact of weight on cancer risk. These studies are more expensive and time-consuming than retrospective studies, but provide more specific data. Retrospective studies begin with people who already have illness and look backward for characteristics or conditions that marked them as being different from people who do not have that illness or problem. These studies were critical in identifying risk factors that led to the development of AIDS. Researchers saw an abrupt increase of Kaposi sarcoma and observed that the men who developed this cancer often eventually died of general failure of immune system. Studies determined that anal receptive sex without use of condom is related to the disorder. An example: a retrospective study examined groups who had participated in behaviorally based weight management programs that were diagnosed with type 2 diabetes. Some experienced resolution of their diabetes through improvement of the regulation of blood glucose. Others continued to have problems with blood glucose regulation. These types of studies are dependent on the accuracy of historical records, and they sometimes rely on subjects' own recall, which may be distorted by fact that they already have the disease. These are also known as case control studies, because people who resolved problems, cases, are compared with those who still showed symptoms, controls. For example, Those whose diabetes improved lost about twice as much weight as those who continued to have glucose regulation problems. Natural experiments are similar to ex post facto design in psychology. The researcher selects an independent variable but does not manipulate it. For example, Fuchs in 1995 looked at women who had pre-existing rates of alcohol consumption and compared for death rates from cardiovascular disease, or CVD. After 12 years, women in the light and moderate drinking groups had lower death rates from CVD than non-drinkers, but heavy drinkers had higher rates of mortality than non-drinkers. Experimental investigation. Because of problematic ethical considerations, experimental prospective studies are quite rare. For example, there would be ethical problems for a researcher to assign one group to a high-fat diet and another group to a low-fat diet. Consider the following example of an experimental investigation. Reducing tanning booth use, Gibbons, 2005. This was a new type of intervention where college students were randomly assigned to get their picture taken using UV photography that highlighted damage to facial skin caused by previous UV exposure. Both groups, control and experimental, were given verbal presentation and written material on consequences of UV exposure and sun protection measures. The subjects who viewed their UV photos reported less booth use at a follow-up session 3 to 4 weeks later than did the students who were not shown a copy of the photo. One problem to consider here is that it was based on the subject's self-reporting. Maybe they lied. Two categories of experimental studies: clinical trials and community trials. Clinical trials test the effects of the independent variable IV on individuals. Randomized clinical trials, RCT, are conducted by healthcare professionals to evaluate treatment or intervention and its effectiveness over time. An example would be 3 large clinical trials that randomly assigned people to take beta-carotene pills or placebo. The conclusion of the investigation was not only did beta-carotene fail to protect against cancer and heart disease, but it might increase risk of developing cancer. This is unusual because most of the time when lab studies, animal studies, and observation studies point in the same direction, clinical trials confirm these results. Note, the subjects in the beta-carotene study were all male physicians. We would guess also white, so we're not sure if the finding generalizes to females. Community trials test the effects of the independent variable on a group. For example, a researcher compares communities where people in one city receive information on the benefits of reducing cholesterol and another would not. Unlike community trials, where one community is exposed to some experimental treatment and compared to another community that is not, community studies, such as Alameda County study, are observational and look at a single community. The Alameda County study is a classic that you should be familiar with. In 1989, Kotler and Wingard analyzed the effect of occupational, marital, and parental roles on mortality in Alameda County. For married working women, the number of children had virtually no effect on mortality. For single working women, having more children was slightly related to increased risk of death. Housewives had a significantly elevated risk of mortality when they had 4 or more children. The number of children had no effect at all on mortality rates for men. 3 basic principles that underlie search for medical truth. You must compare like with like. Groups you are comparing must be the same except for one factor, the one you are studying. The problem is not so much differences that are known, but those scientists are not aware of. For example, the Women's Health Initiative clinical trial that we discussed earlier found women taking estrogen had more heart disease and increased risk of breast cancer than those who did not, even though earlier studies found an advantage of estrogen. But those who faithfully take meds for years are likely different from those who don't. Note, age seems crucial in this case. Those who receive hormonal replacement therapy, HRT, around menopause and for no more than 5 years obtain benefits with fewer risks. However, women over 60 are now generally advised against HRT, especially if there is a family history of heart disease or breast cancer. One of the advantages of RCT is that differences among individuals will be randomly allocated across groups. The bigger the group, the more reliable the conclusions. Large clinical trials trump other studies that have come before because of their scientific rigor. Now let's consider how we determine causation. The risk factor approach. Although risk factors do not derive from experimental studies, they can determine the probability that a person will develop a particular disease. 7 conditions that allow for inferences of causality are as follows. A dose-response relation. A direct, consistent relation between an independent and dependent variable. Relation of heavy, moderate, light smoking to mortality. The prevalence or incidence of a disease should decline with the removal of the possible cause. For example, reducing fat intake lowers cholesterol. The possible cause must precede the disease. The cause and effect relation between the condition and the disease must be plausible. It is consistent with other data and makes sense from biological views. Research data must be consistent. Even consistently weak results might still suggest causation if a meta-analysis of those studies reveals significant results. The size of the relative risk, RR, the ratio of the incidence or prevalence of a disease in an exposed group to the incidence or prevalence of that disease in an unexposed group. The study's design. Experimental designs yield clearest info on causality.